All right, let's look at some ways that we can apply what we know about the relationship, like we talked about in the first video, 811, the relationship between the unit circle and these trig functions and the graphs of these trig functions. So we're going to start by talking about a point that's rotating around a circle of radius 3. Let's stop right there and draw something. Okay? We have a point that's rotating around a circle of radius 3. Just like all my circles. Terrible. All right. So there's some point, and this point is moving around a circle of radius 3. It's centered at the origin. All right. So what we want to know is find an equation of the function f of x showing the value of the y coordinate. So we're specifically caring about the y coordinate here as a function of the angle of rotation. This is the y coordinate. That's going to be our output, our f of x. And the angle of rotation, that's going to be our x coordinate. Well, don't say x coordinate, our x value in this function. Maybe let's use, well, we have to use x. But x is the angle, not the x coordinate in this case. So it's a little confusing. So let's look at how this thing changes. The y coordinate, when x is 0, this is an angle of 0. Right? This is where the y coordinate starts, at that blue dot. So f of x, we know that f of 0 equals 0, right? We start at 0. When the angle is 0, this y coordinate, this y value, this height is 0. And as it increases, when the angle is 90 degrees, the y coordinate, the angle is 90 degrees or pi over 2, the y coordinate is 1. Well, no, it's not. On the unit circle, it'd be 1. But we have a radius of 3 right here. Right, so here, y equals 3. Here, y equals 0. Here, y equals 0 again. And here, y equals negative 3 again. So we're just writing down information. Pi radians is 180 degrees. 3 pi over 2 is 270 degrees. Just trying to write information down because we want a function to show this. Well, what's a function? A sinusoidal function with period 2 pi. It starts at 0 and then goes like this. Well, this is sine. Okay? Starts at 0 is sine. Starts at the maximum is cosine. So what we're going to do is we know this is a sine graph. And the question is there anything else going on? Amplitude, period, phase shift, vertical shift. There's no vertical shift because it starts at 0. There's no phase shift, again, because it also starts at 0. The period is 2 pi. Well, the period of this is 2 pi, so we don't need to have a b value. We don't need to adjust the period. The only thing we need to adjust is the amplitude. Sine normally goes between positive 1 and negative 1. We're tripling the amplitude. So this is our function right here, showing the y value, the y coordinate as a function of the angle rotation. Okay, do another problem. A weight is attached. Let's draw a picture here. Say there's a board, and then there's a spring, pretend that's a spring, and then there's a weight. So a weight is attached to a spring which is hung from a board. As the spring moves, right, because the weight is going to be bouncing up and down, as the spring moves, the position y relative to the board ranges from -1 inches, that's the closest it ever gets to the board, right? So the closest it ever gets is real coiled up right here, and this distance is +1. We're 1 unit below the board. And that's at time t, x equals 0. And the biggest it oscillates is 7 inches below the board. Okay, so sometimes it oscillates really far down. That's going to be 7 inches when x is equal to pi. Assume that y is sinusoidal and sketch a graph and find a cosine function with this property. So here's what we know. We know it's going to be cosine. Now it's going to be y equals something to do with cosine. And we know a couple other things, right? That originally, at time 0, we're 1 unit below, right? That's what we were told right here. We also know at pi, right, this is the maximum. We know at pi, we're 7 below. We know that's the minimum. So the question is, what's our amplitude? Well, the difference, right? The difference between these is 6. The amplitude is half that. Is A negative? Oops, half that. Is A negative or positive? Right? Cosine is what it wants. Cosine starts at the maximum, at the top. So if we start at the bottom, we'd have to include a negative to compensate. But cosine starts at the top, and we're starting at the top here. That's great. So no phase shift or negatives. That's nice to know. Because if it didn't start where we wanted it to start, we'd have to either flip it upside down with a negative, or we'd have to move it side to side with a phase shift. All right. What else do we need to know? We need to know the period. What is the period here? It's kind of hard to see. The maximum, kind of think of a little sketch here. We start at the maximum of -1. And then when we get to pi, we're at the minimum. So we're kind of looking like this. So the period is going to be how long does it take to get to the maximum again? Well, to get to the maximum again, it's just going to be the same thing over and over again. We know it has to behave like this, right? Going from max to minimum took pi, so going back to the maximum is going to take another pi. We know the period has to be 2 pi. Which again is really nice because that means our b value is 1. Because period is 2 pi divided by b. It's just cosine of x right here. But we do have a midline, right? The midline is not y equals 0. We have a vertical shift here. Where's the middle of this? Where's the middle between the maximum and the minimum? Well, the amplitude is 3. So we could just either go 3 down from -1 or 3 up from -7. Either way, we're going to get -4. And this right here should be exactly the graph that we want. So let's visualize this. Y equals 3 cosine of x minus 4. Let's visualize this and see how we're doing. Y equals 3 cosine of x minus 4. We're saying our midline is -4. So it looks like this. We're saying we're starting at time 0. At time 0, we should be at -1. Good, we have that. At time pi, we should be at -7. Good, we have that. So that's really good to kind of double check our intuition right here. And now we need to sketch a graph. Okay, what we're going to do, go to the next page and get ready to sketch. All right, so we're starting. So we're thinking about where we have to go, right? Wait, hold on, Jason. Let's use graph paper. Good idea. I was wondering why things were feeling so difficult. So -1, -2, we can count by ones, no problem. But notice our period is in terms of pi, right? So we actually want to have slashes that has to do with pi. Notice that this is pi over 2. So counting by pi over 2 would probably be pretty useful. All right, so this is pi over 2. This is pi, 3 pi over 2, 2 pi, 3 pi, 4 pi, etc. Okay? Each one is half a pi. So you have to choose labels that make sense here. And Desmos can help with that, but it also has to work with your period and stuff. And that's kind of the tricky part. So let me know if you have questions about that, if that part doesn't really make sense. So we're starting at 0, -1. We hit the midline at pi over 2, -4. We go down all the way to -7. Let's graph the midline. -4. Graphing the midline is usually really, really helpful. Get to the minimum at pi, -7. Whoa, wrong color. And then get back to the midline at 3 pi over 2. And then back to the maximum, midline, minimum, etc. We can just continue on with this pattern to sketch our graph. All right, and that's a good answer. Let me know if you have any questions. I think we finished the problem. Assume that y is sinusoidal. Sketch the graph. We did that. Find a cosine function. We did that. We're good to go. All right.